Hi, I'm Aishani, and today I'm going to explain what flux is. No, unfortunately, it has nothing to do with the flux capacitor from Back to the Future, but flux is still pretty cool. Let's say you want to bake some brownies. You mix all of the ingredients and put everything into the oven. As that glorious chocolate aroma wafts into your living room, you begin to wonder, how much heat is flowing through my brownies right now? Flux can help you calculate that. To answer this question, we can begin by representing the heat flow in your oven as a vector field. We'll call this field F. Heat will flow from higher temperatures over here to lower temperatures over in this region. Notice how the left side of our brownie has all the vector field arrows pointing straight into it, whereas the top side of our brownie has no arrows entering it at all. The arrows entering and exiting the surface give us a good idea of how we can define flux. It's how much of something, in this case heat, is flowing through a surface, in this case a side of brownie, at any given point in time. You might be wondering, how can we calculate flux? After all, we still need to find out how much heat is flowing through those brownies. Calculating flux is actually quite intuitive. As you can imagine, it starts with multiplying the vector field by the area through which it is flowing. But sometimes we have to deal with surfaces which aren't as friendly as your standard batch of brownies. So we have to throw in some integrals, which lets us find the flow through each itty-bitty small piece of area and then add all those fluxes up. But then we have to account for that whole thing where no arrows will enter the surface if it's parallel to the field. So we use a dot product. This is kind of like multiplying everything by the cosine of the angle between our field and the surface. The dot product allows us to only account for the component of the field which is perpendicular to the surface. Speaking of perpendicularity, we can also calculate flux using a unit normal vector, which can be denoted as n hat. N hat is a vector with a magnitude of 1, which points in the direction normal or perpendicular to our surface. And voila! There you have it, flux. Now brownies are great and everything, but heat flux is just one type of flux. For example, this handy-dandy concept called Gauss's law lets us use electric flux to find the charge enclosed by a surface. We also have Faraday's law that allows us to calculate how much voltage is induced by changing the magnetic flux for a coil of wire. Yup, flux is the best. Now go forth and find the heat flowing through those brownies.